In this video, we're going to look over percent calculations. You should have watched the previous video, which discusses what the terminology is, and you may want to review your calculations in your math class about how to do percents. In this one, we will be focusing on the actual calculation, so you will want your calculator to use while you're watching this video. So let's look at how to do some of these calculations. There are basically two types. We're going to have the find it and the use it. In the find it calculations, we're going to be looking for the percentage. In the use it, you're going to be given the percentage, and we're going to use it to find the amount of solute. As we look at each type of concentration, we're going to have a short discussion about when you use which one. So when we look at percent concentration, the most common place that we use this is when we have a mixture with many different solutes. So when we look at the air, we say it's 80% nitrogen and 19% oxygen and 1% argon and 0.1% hydrogen, whatever the numbers are. We have a whole bunch of different things that are in the air, and so normally we use a percent concentration for that. Percent calculations are also used when we have fairly large amounts of solute in comparison to the solvent. Generally speaking, we have another system that is used when we have very small amounts, what we call trace amounts. But for percents, we have a fairly large amount of both the solute and the solvent. Before we can start solving a problem, we need to figure out what type of problem we have present. So we are going to see later that we have some other mathematical calculations to do. So the first thing we're going to need to do is figure out what type of problem it is. Is this a percent problem or a molarity problem or one of the other sets? And then the second thing is to find out, is this a find it or a use it? And then the last thing is, once we know whether it's a percent problem, we know if it's a find it or a use it, we're going to decide what type of percent we're looking at. Is it by mass, by volume, or percent by mass volume? So let's start with the easy one, which is, how do we decide if this is a percent problem? In this case, we have 4 different questions, and we want to decide what type of questions are they, classifying that as a percent, a molarity, or one of the other calculations. So when I look here, I can tell that this is a percent calculation because it has percent in the question. So we're given a percent, or we're looking for a percent in these questions, and you'll see that percent sign or the word percent somewhere in the question. That tells you that we're doing some type of percent calculation. Next, we need to decide if this is a find it or a use it type of problem. So again, we're going to look at the question. It should tell us what we need to know. And in this case, we see that it says calculate the percent. That would be a find it. Here again, we see calculate the percent. So again, it is a find it. Next, we're going to look at the next one, and it says that I have this percentage. So if I'm given a percentage, I'm going to use it because I already have that percentage. And the final step before we do some calculations is to decide which type of percent calculation do we have. So we now know it's a find it or a use it. We just need to know, is the problem a percent by mass problem, a percent by volume problem, or a percent by mass volume? So let's read each one. So for question number 1, we see that it says calculate the percent by mass. So that'll be a by mass problem. For number 2, it says calculate the percent by mass volume. So of course that would be a mass volume calculation. For number 3, we're going to see that it says that I have a 3% m over m. That means it's a by mass type of problem. And for the last one, number 4, we see that it says how much is required to make a 4% V/V, which means it's a by volume type of calculation. Once we have all of that information, we can now set up the questions, and we'll do those one by one. Okay, so let's apply the process. First, we find out what type of problem it is, and we see that it is a calculate the percent problem. We see that that means it's a find the percent problem, and finally we see that it is by mass. For our percent calculations, we're always going to have our solute on top and solution on the bottom. Next, we're going to see that this is a find it. Whenever we have a find it problem, that means we're going to be multiplying by 100%. And in the last step, we see that it says by mass, and that means that our units should be in mass units. In this case, we're going to use grams, so grams on top grams on the bottom. Now all we have to do is put in the numbers. So let's read the question carefully. So reading it carefully, we see that this solution contains 5 grams of silver nitrate and 20 grams of water. You need to identify what is the solute, what is the solvent, and what is the solution. So in this case, we see that we have 5 grams of AgNO3, and that is the one that we have less of, so that is our solute. Then we see that we have 20 grams of water. And here's the tricky part. When it says just water, that is not the solution, but the solvent. So now we have to remember, how do I find the solution? So recall that the mass of the solution will be equal to the mass of the solute plus the mass of the solvent. So in this case, we have our 5 grams of AgNO3 plus our 20 grams of water. Add them together and we get a total of 25 grams of solution. So according to our calculation, solute goes on top. In this case, we're going to put in our 5 grams of AgNO3 on top, and on the bottom we should have our solution. And in this case, we want to make sure we have the solution, so we're going to add the 5 grams of AgNO3 and the 20 grams of water to get to our 25 grams of solution on the bottom. And finally, we put this into our calculator. We put in 5 divided by 25 times 100, and on your calculator you should not hit both the percent and the 100 or it'll multiply it by twice, and our answer will end up with 20%. And now we need to make sure we have the units, so we're going to put m over m. On the practice sets and on the exam, you'll see that it always asks you to write it to 2 decimal places. So in this case we would write 20.00, and again percent m over m. Now let's look at number 2. Here we can see that it is a percent calculation because we have the percent part. Since we're doing a concentration calculation, in this case percents, we're going to that tells us to put solute on top, solution on the bottom, and because it's a calculate the percent, that means that we're going to multiply by 100. Next we see that this is by mass volume, so that means we're going to put the mass on top, we'll put grams, and on the bottom we're going to put the volume, and that'll be in milliliters. And now we read the rest of the question to find out what is the solute, what is the solvent, and what is the solution. So let's read it. It says this has a solution that contains 35 grams of CaCl2, calcium chloride, dissolved in enough water to make 200 milliliters of solution. And so we know that we have 35 grams of calcium chloride. That's going to be our solute. Put it on the top here with our grams of solute, and then we're going to dissolve that in enough water, water is our solvent, to make 200 milliliters of solution. Notice that this says 200 milliliters of solution. It doesn't say of water, so that means it's already added together. So we put the 35 grams of calcium chloride on top because it's the solute, and we put the 200 milliliters of solution on the bottom because it is already the solution. And finally, we put this into our calculator. We put in 35 divided by 200 times 100, and we end up with 17.5% m over v because it's a mass volume, and then we'll put calcium chloride since that's our solute. And finally, just writing this into the correct form for the online assessments, we're going to put 17.50 because it's going to be asking you for 2 decimal places. Okay, let's look at this question, which asks how many grams of sucrose, table sugar, would be needed to prepare 250 grams of a 3% mass per mass sucrose solution. So when we start this question, we're always going to start with, is it a percent question? And yes, it is. We see the percent sign there. So this one is a percent question, not molarity, not molality, nothing else. And when we do these concentration questions, we're always going to put the solute on the top and the solution on the bottom. And then the next step is to find out, is this a find it or a use it? So in this case, we are given the percent, so that means this is a use it. For the use it problems, that means that the 100 will go on the bottom of this fraction rather than the top. Next, we need to figure out what units to use, and this one does say mass or mass percent. And so that means that we're going to use grams on top and grams on the bottom. Now let's see if we can identify our solute, our solvent, and our solution. In this case, we read that we have 250 grams of, and then it has some 3% sucrose, but the final part is solution. So it's 250 grams of solution is the amount that we have. And it also says that we have a 3.0% mass per mass sucrose solution. So the word sucrose is telling us that the sucrose is the solute. When we're given a percent, it tells us that that is for every 100 grams of solution, there are 3 grams of solute. So we're going to go ahead and write that 3.0 on top, where it goes with the sucrose, and on the bottom we'll keep that 100. So what's the other part we know? We know that we have 250 grams of solution. If we multiply that by our 3%, you should see that the grams of solution cancels out, and it will tell us how many grams of sucrose is present. Generally, I would prefer that you write the number that is by itself, in this case the 250 grams of solution, first, and then use the ratio, the one that says 3%. Now that is a ratio of 3 grams of solute for every 100 grams of solution. I prefer that you use that second because sometimes it has to be flipped over. Since the ratio can be inverted, it's generally better to start with the one that is not in a ratio form. So we're going to start with the 250 grams of solution and then make sure that the grams cancels out, but it has to be the grams of solution that cancels out, leaving us with the solute on top. And now we put that in our calculator. We're going to have 250 times 3 divided by 100, and we will get the answer of 7.5. And you'll see that the units left are grams, and that will be of our solute, in this case, sucrose. And again, because of the way that the question was written online for our online homework and our exams and quizzes, you will see that it will tell you to go to 2 decimal places. So you would have to change this answer to 7.50 grams of sucrose. And let's try the last one. It says, how many milliliters of acetic acid would be required to make 50 milliliters of a 4% by volume acetic acid solution? So you can identify this as a percent calculation, and that means that the solute goes on top, the solution goes on the bottom, and since we are given the percent, that means that this is going to be a use it type of problem. We're going to go ahead and put that 4.0 on top. We're going to put a 100 on the bottom because it is a use it problem. And next we look to see which type it is. This says it's a volume percent, which means we have volume on top and volume on the bottom. So we're going to go ahead and put milliliters on top and milliliters on the bottom. Now let's read through it and figure out what our solute, solvent, and solution is. So we have how many milliliters of acetic acid. Acetic acid is going to be our solute, would be required to make 50 milliliters of a 4% acetic acid solution. And the key here is that that is 50 milliliters of solution. And so we see that that is the solution. It does not say what our solvent is, but we don't need it to answer this question. So we have acetic acid as our solute, and the 50 milliliters of solution is the amount of solution that we have. I'm going to start the problem with our 50 milliliters of solution, and then we're going to use that ratio that we came up with, the 4 milliliters of acetic acid for every 100 milliliters of acetic acid solution. And we see that the milliliters cancels out, and that solution cancels out, leaving us with milliliters of acetic acid on top. So let's go ahead and put that into the calculator. We're going to put in our 50 milliliters, multiply that by 4 milliliters, and divide that by 100 milliliters, and we'll end up with 2 milliliters of acetic acid. That is our solute. And again, because of the constraints of our program, you're going to write it with 2 decimal places, so you would write 2.00 milliliters of acetic acid.